Welcome back. In this lesson, we're going to look at the system of the Earth and the Moon and the Sun. And so much needs to be understood as we look at the day-night and the seasons and the tides and the eclipses. And there's so many different aspects of how that the Sun, Moon, and the Earth work as a system together. So let's look at some examples. So this is a very important set of studies to talk about how the Earth relates to the Sun. So we're going to see how the Sun comes up in the daytime, how the Moon comes out at night, the phases of the Moon, the Moon's effects on the tides, the seasons. There's so many different aspects that we could look at. So first of all, we're going to look at day and night. So the Sun is staying put in relative to the solar system, but the Earth is not just moving around the Sun, but it's also spinning on its axis. So if you think of it being relative to the Sun in the same place, as it spins around, you're going to get light and dark within one 24-hour period, and that is that's the hours of the day. So you can have midnight, which is away from the Sun, where the Sun is on one side of the Earth and a location is on the other. You can have daytime, where the Sun is in the sky and that area of the Earth is bright, and then you can have the intermediate times of morning and evening. So there are a few ways that you can demonstrate that the Earth is rotating. An easy one is simply to set up a large pivot. If you have a pivot or a large pendulum, say hanging from the top of a tall building on the inside of a tall room, you'll see that the pendulum should swing back and forth and back and forth, but because the Earth is rotating, it's going to move that pendulum a little bit and set it moving within a 24-hour period. And they would have concentric rings or balls or something around the circle, and every 15 minutes or so, the pendulum will knock into the next ball or knock over the next block or something like that. That's called a Foucault pendulum. Another evidence is the fact that the winds are not straight. The winds are bent as a result of the Coriolis effect. The Coriolis effect, remember, is the Earth is moving out from under the air. The air is not moving necessarily with the Earth, and as such, the bend of the Earth is actually bending that what would be normally straight air is being bent by the turning of the world. So the length of our day is a little bit more than our solar day, because if the Earth were not going around the Sun, if it was staying in the same place relative to the Sun, then our solar day would be the same each day. Our observed day is just a little bit longer because it's moving forward. It's not just pivoting around its axis, but it's also moving forward into space just a little bit, because it takes 365 days for the Earth to go all the way around the Sun, and that is called rotation. And then rotation on its axis and revolution around the Sun. So in terms of watching the different stars every single night, you have a slightly different sky. Every 3 months you can have a completely different sky at the same time in the evening, and it's because as the Earth is going around the Sun, you're seeing the stars beyond the Sun change. Because the Earth is moving in space relative to the Sun. Another interesting and difficult thing to get in your mind is the idea of seasons. So the Earth has a tilt to it. It's about 23.5 degrees, and as the Earth is going around the Sun, the tilt remains the same. So if the tilt remains the same, but the globe is spinning, is revolving around the Sun, you'll see. Right now, this is winter solstice. It's the northern hemisphere is away from the Sun, and on the other side, 6 months later, it's going to be summer solstice. The northern hemisphere is pointed towards the Sun. The equinoxes in the spring and the fall are going to have the sun shining equal on both the northern hemisphere and the southern hemisphere. There's not one that's less than another. So the tilt is responsible for the seasons. So the solstices are the longest and the shortest day. So June 21st is the summer solstice in the northern hemisphere. It's the winter solstice in the southern hemisphere. So one day can be two different solstices in the same Earth, depending upon what hemisphere you're living in. The equinoxes would be the same. So in the north, you would have spring equinox on the same day that you would have the autumnal equinox in the south. The altitude of the sun changes as that tilt appears to change in the sky. So you have the equinoxes where the sun is equal in the sky. The sun is low in the sky in the winter and high in the sky in the summertime, and that allows it to be warmer in the summertime in whatever hemisphere you are, and colder in the winter because the angle of the sun is shining the same amount of light on a larger surface, and so it's a less intense light, and so it's a colder light. There's less energy. The phases of the moon are pretty hard, I think, to try to understand. What's happening is that the Earth is not just spinning on its axis and not just revolving around the sun, but it has a satellite called the moon that's going around the Earth. And so as it's going around the Earth, you're going to get light shining in different places on the moon at different times. So you can see right now it's fully bright, but the Earth sees it as dark. Now it's across from the Earth, and the Earth sees it as full, and now it's going away, and now it's going to be dark again, and now it's starting to grow, and you can see that the light is going to go from the right to the left, and then the shadow is also going to go from the right to the left as it goes around. So you'll see a new moon, okay? Then as it grows, then you'll see a full moon, and then it starts to wane. So you have waxing is getting larger, waning is getting smaller. So this is something that simply just needs to be looked at until some sense is made out of it. Another interesting aspect of the moon is that it's in synchronous rotation. That means that it takes 1 month for the moon to go all the way around the Earth, but it also takes 1 month for the moon to go around its axis. So it takes 1 month for 1 day on the moon. If you think of a day as being light and dark and back to light again, that's 1 day. Well, it takes 28 Earth days for 1 day to transpire on the moon. And because those numbers are the same, 28 and 28, we're always looking at the same side of the moon at all times. That's called synchronous. It's synchronized orbit. Something that we've mentioned before when we talked about the ocean was the tides, and the moon has the most pull on the water, and so you're going to have, when the moon is, wherever the moon is, you're going to have a bulge of water. When the sun plays part in this, the sun can either add to the pull of the moon and make the high tide higher, or it can actually subtract from the moon's pull if it's at 90 degrees and make the low tide lower. So this right now is neap tide, that's low tide lower, that's a spring tide, that's high tide higher. An eclipse is when something is in the way and casting a shadow. So if you have a solar eclipse, what's going to happen is that the sun is going to have the moon in its way. And so some place on the world is going to have the shadow of the moon cast on the ground in such a way that they can't see either part of the sun or the entire circle of the sun. And that's called a solar eclipse. So the moon is in the way. Notice that you've got a dark area in the inside called the umbra, and then you have a semi-dark area on the outside called the penumbra. You're going to have that in all cases of eclipse. So if you were to have the sun is obscured, okay, so looking at the sun was the previous slide, you would see dark over the sun, but you are going to see a dark shadow along a certain line, and if you're on that line, you will have a eclipse of the sun. So in addition to the orbit of the moon going around, you're going to have that there's a tilt to the moon's orbit, so that the orbit is not right at the Earth's equator, but there's a slight tilt to it, and so for that reason the distance from the Earth to the moon changes at certain times. So you have the closest point, which is the moon's orbit, okay, that is the perigee, and then the farthest point is the apogee. Okay, you're going to have the same idea when you have the Earth in relation to the sun. You have a close point to it. The Earth's close point is called the perihelion. Helios is from sun. Perihelion, and then aphelion is the farthest point from the sun. A lunar eclipse is exactly the backwards. This is where the Earth is getting in the way, and the Earth is simply blocking the light from the sun on a full moon. You have a full moon. We can see the whole disk of the moon. The Earth gets in the way, and suddenly now part of the moon grows dark. Sometimes it'll go red. You'll see a red or a brown tinge to the moon as well.